All right, welcome. So since we've got kids finishing up their test, I thought those of you that are already done or get done early could just hop onto Moodle and view this video and then hopefully know how to do the notes and would be good to go as far as that goes. So that's the intent of this. Moving on to chapter 6, solving systems of equations by graphing. So things to note, system of equations means that you find an x value and a y value that are the same solutions to two different equations. So instead of just solving for x separately or just solving for y separately, we need to find values for both x and y that satisfy or complete two different equations. We use a variety of methods throughout chapter 6 to help us do that, but the first one that we use is graphing. Big thoughts, like I said, graphing today. So basically what we want to see is we'll graph two lines, two separate lines. So we'll have the equations of two separate lines and we'll graph those in the coordinate plane. And then we'll just see where they intersect, and we'll figure out that x and y ordered pair, and that'll be our solution to the equations. Note that some lines may never intersect, in other words, they would be parallel, and then some lines may always intersect, so they'd essentially be the exact same line. So we'll see what that looks like here on the next slide in kind of a visual format. All right, one solution, which is what probably 90% of the time our line should produce, would just be the lines cross each other once, and this one unique solution, that one unique xy ordered pair, is the solution to the system of equations. Infinite solutions occurs when you've got lines that are on top of each other. So they're the exact same line, just right on top of each other. That means that any point on that line would be a solution. As soon as you jump off the line, you're not going to have a solution that fits, but any point on the line would be a solution. And since lines go on forever and ever, they never end, that's why we say that it's infinite solutions. So again, any point on that line is a good solution. No solution happens when our lines never cross, right? When they're parallel, when they have the same slope. That's what makes parallel lines parallel, as we know from chapter 4. But since they never cross, then there's no solution that exists. There's no x, y that they share. All right, so if I'm to solve this by graphing, get my pen pulled up here. First thing that I want to do is make sure that these are in slope-intercept form. So I'm lucky because both of these are. So I don't know, in this first equation, I've got that m equals, that's awful. M equals -3. I've got that my b equals 10. In the second one, I've got that m equals 1 and that my b equals -2. So at this time, I would want you guys to go ahead and pause the video, graph these two lines. And you can use graph paper to do that. You can make sketches in your notebook. I would use graph paper because we want to be pretty precise today to find that unique XY ordered pair. So go ahead, take a second, pause the video, graph those two lines, and then unpause it when you have it, and I will reveal what the answer should be. All right, welcome back. So hopefully you've got your two lines in the coordinate plane. I'll pull down my screen shade here, and we can see the two lines graphed. So the blue line is the second equation, right? So this is the blue one. And then the top one is the red one. So hopefully graphing is going all right for you. That should be mostly review. But the unique thing we see about these is that their point that they share, the xy coordinate, is at, let's see, what is that, 3, 1. So the solution would be x equals 3, y equals 1. Or if you want to write that in ordered pair form, say 3, 1. That's good. So any version of that is fine. You can say x equals separately and y equals separately, or you can combine them into an ordered pair. Okay? All right, so moving right along here, and we've got another one. This time they're not in our good slope-intercept form. You can use any method of graphing. I just think slope-intercept is probably the best and the one that we like the most. So I'm going to take a second and make sure that these get into slope-intercept form. You can feel free to work with me if you would like. So I'm going to start by subtracting 2x, subtract 2x. That gets me -y equals -2x minus 1. If I divide everything by a -1, looks like I've got that y equals 2x plus 1. So there's my first equation in slope-intercept form. Next, I would want to subtract 4x, subtract 4x. I've got negative 2y equals negative 4x plus 6. Divide by negative 2 across the board. And I've got that y equals 2x minus 3. So there's my other equation in slope-intercept form. Again, at this time, pause the video, graph those two equations. You may have already noticed something about their slopes that would tell you what the solution to this might be. But take a second, graph those two, pause it, and then come back and we'll reveal what these look like. All right, again, welcome back. Hopefully you've got your two lines on your coordinate plane. And if we notice, we've got a case where those are parallel, right? Meaning that they never cross, meaning that we've got no solution. Okay, so this one is our empty set. There's no solution because they never cross. So that unique XY ordered pair doesn't exist. There wouldn't be an X and a Y that we could find to make both of these equations true and have it be the same X and the same Y for each. So there's a good example of no solution with parallel lines. Last one I want to take you through is this one right here. We're lucky because this equation is already in slope-intercept, so we're set there. Just do some quick algebra here. Subtract 6x, subtract 6x. I've got 3y equals negative 6x minus 9. Divide everything by 3. And I get that in slope-intercept to be y equals negative 2x minus 3. Okay. Again, at this stage, it's not a bad idea to look at your two equations and see if that's going to tell you anything about what kind of solution you have. So notice these are the exact same equations, so you should have some ideas in your head going on about what this is going to look like. If we graph both those lines, it's probably just going to look like it's one line, but really what we know is that it's two lines stacked perfectly on top of each other. If you see the theme of the colors I've used throughout, it's been a blue line and a red line, blue line and a red line, blue line and a red line. So I thought I'd be creative and do the combination of blue and red from art class, which is purple. So this purple line is showing that it's the blue line and the red line stacked perfectly on top of each other. And this would be the idea where we've got our infinity symbol for infinite solutions. Any point on that line is good. We don't want to be off the line, but any point found on that line works as a solution. So there's a never-ending amount. There's an infinite amount of solutions. If you feel good about this, you should come up and grab your 6-1 worksheet. Let me know if you have questions over anything. We need to get that clarified before you start your individual practice. But hopefully you found this useful. And good luck. Let me know if you need any help.